Everybody, wow. Is anybody here? Can't even see in the audience. If you're here, say hi. Oh, that's okay. Let's try again. Say hello if you're here. Good morning. No? No? Awkward. All right. Good stuff. Well, thank you for coming. Those of you who are here, I'm going to take your word for it because I really can't actually see into the audience. So there's just, as far as I'm concerned, my friend Luke is here, and that's about it. And that's what? Yeah, and that's about it. So now we're going to go through a lot of code today. I love code. Code is a very important thing. So if you are interested in following along later, not now, not meow, later, grab those bits up there and git clone the repository, okay? Actually, I think I should do that as well, just in case. Sorry, it's been almost a day since I've done this. CD working. Good. Let's just make sure that I have everything I need. Good. So, grab the bits. Please don't hesitate to follow along. I'm on the internet. I love the internet. The internet is the largest community after all, and so I hope you're there as well. How many of you are on Twitter? Twitter. I can't really see. Oh, some of you. Good stuff. Right on. Twitter's the new ICQ, right? So IRC rather. So good stuff. Be on Twitter. Don't hesitate to reach out to me if you're online. Find me there. I'm at Starbucks Man. I'm happy to carry this discussion forward online. What about email? Email. Anybody at all? No. Okay. Well, I'm there as well. So if you have questions or comments or feedback or whatever, please don't hesitate to reach me. A little bit about me. My name is Josh Long. I'm a Spring developer advocate on the Spring team at Pivotal. I'm the author now of going on 5 different books on building distributed systems. The latest and greatest is Cloud Native Java from O'Reilly, due as soon as it can be done. I'm also the lead on videos. I'm the leading contributor of bugs to many fine open source projects like Spring Boot and Spring Cloud and vaadin activity and Spring integration, Spring Batch, etc., etc., etc. So I'm out there. I'm also I have the privilege of being a Java champion. And so as part of that function and as part also of what I do at Pivotal, how many of you have heard of Pivotal? Pivotal. Good stuff. So some of you. So Pivotal is the new home of Spring, right? Lots of great open source bits at Pivotal, not the least of which is Spring. So how many of you have heard of Spring? Spring. All right, good stuff. So what about Tomcat? Apache Tomcat. Anybody? Nobody? Okay. What about RabbitMQ or Cloud Foundry? Okay. Yeah, some of that, right? So lots of good open source stuff. And we care about open source. It's in the DNA of everything that we do, but it is not a destination in of itself. What we care about is helping users and customers and community successfully, quickly, and safely deliver software into production. We believe that production is the happiest place on earth, better than Disneyland. If you walk around the offices, you'll see people with brochures to production, right? That dream getaway for production. Forget Hawaii, right? And we see organizations often struggling with this. How do they get their software? How do they get their business differentiating functionality into the hands of users faster than the other guy or gal, right? And that's a tough question. We see today that organizations are spending a lot of their time trying to go faster, right? That's a big deal in the modern world where every organization, every vertical that we've seen today is being disrupted by software. Who is the largest taxi company? What is the largest taxi company in the world? No? Anybody know? Uber? Yeah, there you go. Good stuff. What is the largest video rental service in the world? Right? Netflix? Do you have Netflix here? You must. Surely. Yeah? Good stuff. So We have lots of different organizations that are now dominated by software, and those organizations that are able to deliver software faster are the ones that have the highest chance of winning, which is good, right? But that means that we have to get there quicker. We have a lot of non-functional requirements that gate our ability to deliver business functionality into production. These non-functional requirements are often not just something you can leave towards the very end. They're things that you have to address up front. When you're building applications, you face a lot of challenges. Indeed, application development is hard. And so what we're going to look at today is how to use something called Spring Boot, which is an opinionated approach on Spring and other ecosystem technologies to quickly develop an application and get it up and running. The opinion, for those of you who are wondering, by the way, is that production is awesome. Okay, so we're gonna now go ahead and move on. This is the last of my slides. Do you want me to get rid of the crazy GIF now? Yes? We can leave it here. It's fine. Anybody? No? Okay, fine. There we go. That was fun. So those are my slides. What'd you think of those? Those are I worked hard on those slides. Did you like them? No? Nobody? Okay. Well, I like them. They won a Grammy. They did. Best soundtrack. So anyway, moving on. We're going to build a new application. We're going to start our journey today at start.spring.io. Now, if you are building an application today and you're going to start your journey with Spring, go to start.spring.io. This is my second favorite place on the internet after production. Keep this under your pillow. If you suffer from heartburn, start.spring.io. If your children are restless and can't sleep, start.spring.io. If you want for inspiration before your daily cup of coffee, start.spring.io. Again, you can do other things, but this is a great way to start your day. So here you're confronted with some options, some choices that you need to make in your journey to a new application. You have here the choice of what build tool you're going to use. Doesn't really matter. You can use the latest and greatest stable version of Spring Boot or the snapshots or the last stable version as well. And you can also bring in different types of technologies, workloads that you want to support in the application. So I'm going to bring in web support. I'm going to bring in REST repository support. I'm going to use the H2 in-memory embedded database. So there's that. I'm going to use JPA because I make poor life decisions. So JPA, there's that. I'm going to use Actuator for operational concerns. I'm also going to bring in vaadin support because YOLO. I'll bring in Timeleaf. There we are. And I think that'll do for now. We might even bring in the remote shell. There's that. Good stuff. And then I have a choice about what kind of application I want to build. I'm going to build an application called the reservation service. And of course, I could have done this the more exhaustive way. I could have chosen to see all of the options and then manually selected down here the kinds of technologies I'd like to support, what kind of workloads I'd like to support. There are many fine alternatives to JPA, for example, down here that you might use, right? So keep that in mind. You have options for all manner of different technologies, not just to do with application development, but indeed with systems development and infrastructure and all these other things. So do take a look when you have some time. But for now, we've got everything we need. We also have choices we have to make here. Obviously, you can choose the latest and greatest version of Java or the last two versions, but don't choose the last two versions of Java because they're end of life, friends. That's a dangerous way to run a railroad. I wouldn't advise that at all. Choose Java 1.8. It's good stuff, hot sauce. Here you have choices about which language you can use as well. So I've chosen Java because I'm a Java champion, not a Kotlin champion, for example. But these are all great choices as well, and it really doesn't all that much matter in terms of what you get as an output of this process. And then finally here, we have the most important, or rather most unimportant decision to make. If by some accident of physics, you are stuck in the very distant past, unable to move forward to the future, which is really only today, so it's not that impressive, then choose .war. But if you're here with me in 2016, then choose .jar. This is a big part of my personal philosophy of make jar, not war. Now, again, You have choices, you have options. Do the thing that works for you, okay? Do what works for you. I'm gonna hit generate now, and that'll give me a little zip file. And again, this zip file is otherwise pretty Spartan. You can import this into any, it's a Maven project, so you can import it into any ID you like. How many of you are using IntelliJ? Okay, well, seems a plurality there. What about Eclipse? Okay, also very well represented. NetBeans? Good stuff. I like NetBeans as well. Awesome. Well, choose what you like. It doesn't matter. How many is the one guy using Emacs here? Are you here? No? Okay, not this time. Got away from him this time. So let's see. Let me close some code off here. Goodbye. And goodbye to this. Here we are. Okay, so that's this, and this is my application. Should I make this a little bigger? I think I might have to. Font. It's bigger. Okay. So what you have here is a Maven project. So this is a typical Maven build. You know, doesn't look too different from any other Maven build that you've probably already seen, I suppose. You have here a parent POM. In this parent POM, we've taken the liberty of level setting common ecosystem dependencies for you so that you don't have to really worry about it. So for example, all these different projects that have to integrate together, like the commons libraries, the Dropwizard metrics library, cache, the Flyway or FreeMark or Elasticsearch integrations, H2, Hazelcast, Infinispan, Jackson support, all these different common ecosystem projects, as well as the Spring projects, right? So we've level set all these versions for you. You don't have to play whack-a-mole trying to make the version ranges line up. If you import one project and another project and they share a common dependency on a third project and those versions conflict, we've managed that for you. Indeed, we have people on the Spring team, not a bit of hair on their bald heads. They've done all the work to make this work for you. All their hair's gone for you, right? So this is the sacrifice that we make to make this kind of nonsense much simpler. The result is that now I can go back to my build here, and I can bring in these Spring Boot starter dependencies. These starter dependencies correspond to the checkboxes that we selected on start.spring.io. These are opinionated dependencies. They don't actually have any code in them. All they do is bring in other dependencies. They just manage the versions and bring in everything you need to be productive with a given workload out of the box. So here, for example, you can see that I've got Spring Boot starter web. Well, that corresponds to the checkbox called web on the start.spring.io. I'm going to go ahead and comment out most of them, bringing back only my, my domain bit right here, JPA. And then I'm going to leave my embedded database for SQL access here. And I'm going to use this test framework. That's there as well. You might recall that I didn't actually select or unselect test. That was just implied. It's 2016. We're all writing unit tests, right? Right? Bueller? Nobody? Okay. Good stuff. Well, leave that there. And now we have in our application itself a entry point into the application, just reservation service application. It's a public static void main. Naturally, we also have a stub empty sort of unit test there as well. And then that's about it. That's most of what you get from using the Spring initializer, the start.spring.io. And I think you'll agree that this is not all that much. You could have written this code by hand. So what we're going to do is we're going to build a nonsensically simple application to manage an object of type reservation. The reservation corresponds basically to like a reservation you might make at a hotel or a restaurant or something. I don't know. I just wanted something we could play with that'll store some data in the database. So we're going to give it a primary key and a field called reservation name. This will map to a field in the database called reservation_name. I've got another field here called ID. This is a primary key. I'll signify as much by saying generated value, okay? And I'll give it a auto-incrementing value. That's the generated value. I'll make it a primary key by saying @ID. It's a JPA entity, and I'll signal as much by saying @entity. This is Java, so naturally I need to have a few getters. So there's this. I need a few constructors, another constructor for Java, for JPA. So there's that, right? Why JPA? Why? I need a toString method here. There's that. And now we have, most of that noise, this is all I really cared about was this one field. Everything else was to get that one field persisted to the database. And I need some way of talking to the database, right? And so here I have lots of great options, but we're going to use Spring Data JPA. Now, Spring Data is an umbrella project that has lots of different modules underneath it. The goal of Spring Data is to provide best-of-breed access to different persistence technologies. It's not the minimum viable common denominator abstraction across all of these different databases. It's typically the best of each as concisely and usefully as possible. So to support our persistence tier use cases, we're going to use a repository. Now, if you've ever read Dr. Eric Evans's amazing tome, Domain-Driven Design, then you know that a repository is an object that manages the persistence from the business layer to the underlying persistence tier, right? But it's typically boring code. This is not business value delivering functionality. This is what Adrian Cockcroft refers to as undifferentiated heavy lifting. It's stuff that the machine can do. It's stuff that you shouldn't be doing. Nobody's going to ever pat you on the back and say, good job, way to write the best select all from foo where ID equals question mark, right? Way to do the best query that we've ever seen. Nobody's going to give you a promotion for that. Nobody. It's dumb code. It's let the machine do it. Let the dumb machine do it, right? So instead, we're going to let the machine do it using a declarative repository. Instead of writing the code ourselves, we're going to say interface reservation repository extends JPA repository whose object is of type reservation, whose primary key is of type long, right? And this is an interface in Spring Data. You don't have to couple yourself to this interface. You can use annotations to signal that this interface should be used, but this gets the job done. You can see that this interface in turn implies certain methods. So list of T, find all given a sorting condition, given a collection of IDs, delete and batch, delete all, get by ID, etc. We also have here paging and sorting repository. Now, SQL lends itself to ad hoc querying and sorting, but some technologies like Cassandra don't do so well at that. So you'll find that the analogous Cassandra repository doesn't offer support for paging and sorting, which makes sense. Similarly, if I want to create custom finder methods, I want to create a custom query, I can do so here, say, for example, saying that I want to find all of the reservations by their reservation name, right? So this is going to look for the reservation, and it's going to be based on this method name that I get a query that looks something like select all from reservations where reservation underscore name equals RN. But this is obviously pretty agnostic, and this will work pretty portably across different implementations. But I can also write finder methods that take advantage of the best-of-breed features of each persistence technology. For example, both MongoDB and Couchbase lend themselves very readily to geospatial queries. So if I wanted to, I could create a query here that says, find all the reservations by a geospatially indexed point, passing in a Spring Data point as a parameter, you know. So you have lots of options here. I won't go into the details. Now, what I want to do is I want to use this interface, which is going to be automatically implemented for me by Spring Data. I'll have a bean that implements that interface. I'm going to use this interface to now do some setup. I want to insert some data into the database. So I'm going to create a command line runner that just inserts some dummy data. So dummy CLR implements command line runner. And I'm going to say at autowired private reservation repository. And all I'm doing here is I'm telling Spring that I want access to this reservation repository object as a collaborator. I'm doing the thing that you should never, ever do. I'm a little lazy, and I don't have a lot of screen real estate on screen here. So don't do field injection. You should, of course, prefer constructor injection like so, right? So there's that. Come on, computer. So that's the right way to do it. But again, for want of screen real estate, I'm gonna do it like this, okay? So do as I say, not as I do, please. And what we're gonna do is we're gonna create some sample data. We're gonna just insert some simple sample data into the database. There's my first entry. I've got myself. I've got Mr. Hazel. I've got Stefan. There we go. And you need some other names. Can somebody give me a name? Nope, you're not really doing great at this. Shout out a name. Make it happen. How do you spell it? Oh, like that? Sweet. Okay. I suppose that'll do. So for each name, for each name, I'm going to say reservation repository.save, new reservation, passing in the name. Now, again, I'm using a very nice feature here in Java 8 called lambdas. How many of you have had a chance to play with Java 8? Oh, good stuff. So you know that in Java 8, they make it dead simple to pass in bits of functionality without the ceremony of passing in a whole object. Indeed, all I want Java to do in this case is to call a bit of functionality for each record in this stream, which I get very naturally by using this line here. I'm going to also say reservation repository dot find all, giving back a collection of everything, and I'll say for each record, let's have Java just call the printline method, passing into it the argument, the record, each record that it iterates over. And then this will hopefully insert some dummy data and then confirm everything's been written by printing it out to the database. But if you look at what I'm doing here, again, I've told Spring about this object by annotating it. Spring knows to wire up and satisfy dependencies using annotations, but I can also tell Spring that I want to define a bean and provide the construction logic for that bean in a bean provider method. That bean provider method has the benefit of, in this case, not polluting my namespace. I can take all this ceremony out of the public namespace there and just kind of hide it inside this class. So I'll say instead that I want to inject a repository collaborator like this, and I'll return a lambda, which is what I want here, and I'll have that lambda do the same basic initialization logic. Now, what I'm doing here is I'm creating a command line runner. This interface is a Spring Boot interface. It says whenever the application starts up, call this method passing in the variadic string array in public static void main. Args, right? It's a good place to do any kind of batch or ETL or integration or any kind of initialization, anything that needs to happen as the application is ready to handle traffic, right? So there's this. We can go ahead and run it. We'll see it going right now, hopefully, if all goes to plan. Recall that I have got H2 on the class path. I didn't have to specify an embedded database, right? That was the only option for a database, but it is a valid embedded database along with Derby or HSQL. So Spring Boot automatically initialized an instance of that data source. If I had explicitly configured a bean of type data source or specified properties or something else, I could have gotten a data source that talks to any other technology. Now, here are the records. Here's the output. So that worked. But we knew that was going to work. Of course that worked. This is a demo. I don't make mistakes. Instead, I just wanted to show you all this. This is actually what really matters here. This is the ASCII artwork inside of Spring Boot. Now, this ASCII artwork took a lot of people, a lot of really brilliant people, a long time to get right. We have on the Spring team 2 people who are PhDs, doctors, people who worked in their previous lives on nuclear physics, star stuff, the very celestial bodies in the heavens above us for their daily bread and butter. And so it is with great happiness that I imagine that someday, somewhere, someplace, they got a GitHub issue saying, darn it, we need good ASCII artwork. And look at that. It's just gorgeous. Absolutely gorgeous. Now, sometimes people ask me, can I change it? Can I get rid of it? And that's when I usually struggle to resist the urge to start flipping tables, because that's a stupid question. Why would you ever want to get rid of that ASCII artwork? It's absolutely gorgeous. You could override it, and I'll show you how to do that in a minute, but I do want to take a quick second to just talk about a feature that I really don't feel like was of the best inception in IntelliJ. Now, this feature, I think they could have done better. I'm a big fan of the product, I'm just saying, but what the hell? What's that? Why is that even there? Who thought of this, right? And so I complained about this, and I got some help, right? So this is my friend. He's from JetBrains. They work on the IntelliJ product, of course. And I complained about this serious deficiency in their product, and he promised me that it would get better. So let's see what he said here. Tweets and where did we go? There. So this is the hopefully fixed version of that feature, right? Disabled by order of Josh Long, hide banner. So we'll see if that gets in the next JetBrains release, but I think it's going to be great. Now, anyway, let's make JetBrains great again, okay? Let's get that checkbox to go away. Now, you can change the ASCII artwork if you really want to. I can't imagine why you want to, and you have to be like epic level, next level banner art foo master to be able to do this. But if you are that level of adequacy and you can do it, great. So let's see here. If I go to the code. And again, the source for this amazing piece of work is in the code that hopefully you've noted earlier. Okay, oops, caps, copy, downloads, reservation, source main resources. Now all I've done is I've copied this text file into my source main resources directory there. Can you all see that? So there it is right there, ready to help us out. Now Spring Boot by convention will see that that is there, and it'll reload to reflect that. So there's much, different. It's not much better, but it's much different compared to what we had before. Again, unless you can do something like this, do not override that banner artwork. Now, notice that it says meow. Okay. Also, that. Why is that so awesome? Okay, anyway, moving on. So I've got an application that's talking to the database, and it's doing a good job. We've got transactions, we've got persistence, we've got a finder method, but it is 2016, and we can do better. We need an application that exposes information via REST. Now, if you write to the database and you don't expose that information to the REST, did you actually write it to the database at all? This is a philosophical question that I'm sure we've all struggled with in Philosophy 101. The answer, of course, is no, you didn't. Right? So we're going to go ahead and build up a REST API. I'm going to bring back Spring Boot Starter Web. Here's this. And this is going to give me everything I need to build a web application in 2016. So I'm going to say at REST, hello computer, at REST controller class reservation REST controller. There we are. And I'm going to inject the collaborator I need, which is the reservation repository. There's that. I'm going to map this endpoint. I'm going to stand up an endpoint to /reservations. Now, again, you can specify everything you like. Reservations, okay? And it's just a simple endpoint just to read the data from the persistence tier and turn it back to the client. So here's this .find all, and I'll go ahead and run it, and we should see that up and running in due time. Okay, localhost /8080/reservations. Now, this works. I've got a very simple REST API. You should bear in mind that I have a browser plugin that lets me expand and collapse nodes here. That's what this awkward hyphen is before, but it's just pretty typical, boring, mundane JSON there, right? And that's fine, right? That works for us. But again, that's a lot of extra work that I don't feel like I should have to do in the modern world. So what I'm trying to do is to map the business state transitions, the creation, the reading, the updating, and the deleting, to the appropriate corresponding HTTP verbs. That is, after all, the very essence of REST. So to support that use case, I'm going to bring in Spring Boot Starter Data REST, like so. So Spring Boot Starter Data REST. Good stuff, okay? And I'll revisit my code here, annotating the annotation to say repository REST resource, and annotating the finder endpoint here, REST resource path equals by name param rn, and then I'll restart, having done the work that I set out to do in the first place. Oh, that's so good. It's more watery than those other waters. So here's the same endpoint revised. You can see we have the same payloads just as before, but we have extra information here, links. These links are hypermedia. This is an implementation of the design pattern called HATOS, or hypermedia as the engine of application state. The idea is that every REST resource should have information enough in the response for the client to be able to further manipulate that resource without any a priori knowledge. This is a very, very useful thing as you move to the distributed systems world of microservices. You want as much as possible for your APIs to be both humane and self-describing. These links are pretty natural if you think about it. We do this all of the time elsewhere. We say link rel equals text CSS with quotes, of course, source equals foo.css, etc. And that tells the browser, the client, that loads a resource where it can find relevant information. In this case, the relevance is that it's a style sheet, which it can see because it follows this text CSS bit here, right? The browser, the client, doesn't know ahead of time where to find the style sheet. It doesn't have a standard saying it must go to /styles. It looks in the resource and finds metadata, links. This link element in the REST API serves the same use case. These links are also stateful. You can add or subtract or contribute custom links when appropriate for your use case. So suppose you're on Amazon.com and you're buying some products and you add a product to the shopping cart and then you haven't checked out yet. Do you think there's going to be a button next to the products that you've added to the shopping cart offering you a refund? Of course not, right? That doesn't make any sense for the state that entity is in at the time. These buttons come and go when it's appropriate. Similarly, these links only appear when it's appropriate. If the entity is not paid for, then you should not offer a link, for something that is inappropriate for the state it's in. Okay, so that's a REST API. We've got a REST API with hypermedia. If we scroll down, we can see more links. We can see links for the aggregate search results as well, including the search endpoint. If I go to the search endpoint, you can see here that I've got my Finder endpoint, search by name. So there's that. And I say by name, that's cool, RN equals, and who did I choose to add? Let's get my friend here. There we are. So there's the one record I searched for by name. You can see it says by name because it says by name, right? So there's that. And there's the results, and I can look for the canonical representation of this resource and so on. I can also do paging, so I can say page equals 1 and size equals 2. Of course, so this only works on certain technologies. And I've got also links here that describe where I am in the resource set, in the result set, based on the paging I'm doing here. So I can look at the first results or the next one or the current one or the previous or the last one, right? All of that is automatically implied and available for me. Now, this is a very, very humane REST API, but this wouldn't be much of a demo if I didn't have a web application. So I'm going to go ahead and build a simple MVC controller. Okay, so what I'm going to do is I'm going to say @controller, and this is the old school controller. This is the kind we did before REST, right? So I'm going to say reservation MVC controller, and I'll inject my repository there. Here we are. Reservation repository, okay, and I'll say @request mapping method equals get and value equals, and again, this is a demo, friends. This is a demonstration. I'm just having fun. I'm going to use stuff up here that maybe you would never ever use in production, ever in a real life situation. Would you ever, even when very, very, very drunk, ever, would you do some of these things? And I appreciate that. I understand that. So I'm going to say that this URL is mapped to reservations.php. Now, again, don't do as I do. This is a demo sometimes, okay? There we go. Now, a model is just a glorified map. It's a context with keys and values that the eventual template that gets rendered will use to dereference information. I'm going to add an attribute to the model. I'll say the attribute name is called reservations. I'm going to inject the collaborator that I need here, @autowired private reservation repository, okay? And I'll clean that up, and I'll say this .reservation repository.find all, and then I'll return a template here called reservation. So source main resources templates x.html. Now it's looking by convention for that template in that path. This is handled by something called a view resolver, which automatically gets wired up for you by Spring Boot, right? So there's that. I'm going to go ahead and use a specific type of template. And again, you have options. You can use whatever type of template you want. I'm going to use Timeleaf. How many of you have heard of Timeleaf? Timeleaf is a very nice HTML5 sort of friendly, round-trippable templating technology. It's one of many options that you have. So again, you can use, for example, let me see. You can use, for example, Velocity or FreeMarker or Groovy Server Pages or Mustache or whatever you like, really. You can even use, I can't even say it, it hurts me to say it. You can even use JSP. Now, you shouldn't use JSP. Don't use JSP, okay? Now, the reason you shouldn't use JSP is because it's a terrible, terrible, terrible technology, unequivocally based on science. Now, if you are looking for an alternative, you don't have to use what we're providing. There are things on the sidewalk that you will find that do a better job of generating HTML and sending back to the client than JSP. A bloody finger, I mean, literally anything at all would do a better job. So don't use that. If you've ever gone into the office and seen the graphics designers stare at you with that angry look, that very, very unhappy look, there's a reason There's a reason. It's because you've given them JSP and you've ruined their work and their world. If you've ever gone to the office and walked in and had a cup of coffee and you go to your desk and you find a bag of flaming feces at your desk, that's why. That's why. So the trick is, don't use JSP. Now, what you can do as an alternative, I like TimeLeaf. This is HTML5 friendly. It's previewable. You can open this up in Dreamweaver and other design tools, and it round trips correctly. It has display fidelity. You can see that it's kind of like a server-side version of Angular in that for each attribute here, we're going to do some logic, but that's runtime logic, so you don't actually see that here. This previews correctly in the meantime, though, because it is just valid HTML. So here, for each reservation R in the reservation's model attribute, let's print out this div, this bold element, and the span information. There's that. And that should work. So let's go ahead and start this up. See that work? Good ASCII artwork, always good. So now here's the reservations.php, and there you go. Very, very simple iteration of the data. Nothing fancy. I am not a designer. YMMV. Okay. Now, this is one way to build a web application. There are lots of different ways, of course. You might, for example, decide to stick with purely client-side and just use REST. That's fine. You might want to do something a little bit server-side and a little bit client-side. That's okay as well. Or you might want to just punt on the whole thing and let the server-side do everything, because you're not really interested in building a particularly skinned or particularly designed kind of application. You just need something that people can use to work with data. And there's a lot of use cases for that. So we're going to use vaadin. How many of you have heard of vaadin? Vaadin is a nice component-based approach to web application development. It's good for certain use cases, and I think data-driven, form-driven kind of applications are ideal for that. We're going to use this vaadin Spring Boot starter. Now, notice that this is not the same as the rest of them, right? This is from the vaadin team. Works the same way as the ones that you see here from Spring, but this is just contributed by a third party. And we can see here that we had to bring in the vaadin BOM, or the Bill of Materials Manifest POM, okay? So once I've got that, I'm going to go ahead and move my reservation JPA entity into a public type. So here's this. Let's just move that up, okay? Why doesn't that work anymore? Let's just cut and paste it then. Okay. New class reservation. Okay, paste. Good. This needs to be public. Good. And then we can go back to our code here, and we can build a vaadin UI. So I'll say Spring UI path equals UI, and I'll say at theme equals volo. Okay. And I'm going to say class reservation UI extends UI, and I'm going to override the init method, and I'm going to inject, just as I have before, the reservation repository that we need here. So we'll inject that, and in my init method, I need to set up some data. So I'm going to use a grid component, which is a table, to show and then support paging of data. I need to provide to it a data source. So I'm going to provide a new bean item container, new bean item container data source whose data is of type reservation.class, passing in, of course, the data itself, this .reservation repository .find all. Okay, there's that, and I'm going to set that as the content here. Oops, set content components, and I'll make this table as wide as it can get. So I'll say set size full, and then that should give us a simple grid with the information that we want. Okay, so if we go now to /reservations, that should still work. There's that. We go to reservations /, there's that, and then UI. Here's our, I'm making it bigger, but this is a simple client-side widget that displays the data. It's got paging and sorting. It's got some common sense defaults for the labels on the top and so on. And you can customize this very easily. All of this is JavaScript. This actually uses, underneath the hood, it uses GWT or GWT, right? So Google Web Toolkit. The result is that you get blazing fast HTML5 and JavaScript and no server-side generated markup. Again, maybe this works for you, maybe it doesn't. The point is it's dead simple to use it, right? Now this is an application. It's got vaadin. We got an MVC endpoint. If we wanted to do statically served resources, we could put that here. We could just say, hi.html in the source main resources static directory. Hi, right? That works fine. But I can't exactly take this to production just yet. I need to operationalize it. I have a few things that I need to take care of before this can go into production. So what I want is to be able to support operational use cases, right? I've talked about application development, but getting to production here is the goal, and there's a lot of non-functional requirements that gate our ability to do that. These non-functional requirements are things that, as before, are undifferentiated heavy lifting, things that are not very interesting to the business, but that you need to do to support an application in production. Things like metrics and health checks and other things. Again, things that you will never get a promotion for having done. Nobody's going to ever give you a new job or a better job or bigger salary for writing a health check, right? It's boring, dumb, undifferentiated heavy lifting. To support these use cases, I'm going to go back to my build and I'm going to bring in the Spring Boot actuator and the Spring Boot remote shell. Okay, here's this. I also want to support operationalizing the application, so I'm going to make them executable. I'll say configuration executable equals true, and now I'm going to restart my application, having done all that extra work in the build. And what this is going to give me is I can access the application from the standard endpoints, just as before. There's that, right? And hit refresh a few times. Go to reservations. Go to reservations 1, 2, etc. Right? So there's my data. Now if I go to /, I get that. Now I can go to metrics, and metrics shows me an enumeration of common keys and values that the system can automatically infer for me based on the environment. These are metrics that I can, of course, contribute custom values to by injecting a counter service in any of my component code. These are operational telemetry kind of metrics. These are not things that have to do with your business itself, but you can contribute those things like how many orders you process per hour or whatever. You can also use any of the other available metrics writer implementations in Spring Boot and forward or publish these metrics to things via the statsd protocol or directly to things like Redis or to JMX or to Graphite or whatever. You can also use things like Dropwizard metrics, right? If you have the Dropwizard metrics library and you use that and you emit custom metrics that start with the token meter dot, then you get a histogram of that metric. And that's very useful because while these values are nice, they're point-in-time numbers. They don't tell a story. How do you know what this value means to your application? Is it a deviation from the normal behavior? How do you know? You need a histogram. You need some scope of time to be able to understand that. And a histogram gives you, for example, the median, the max, the 95th percentile, the 99th percentile, etc., all relative to a period of time. So it's very, very powerful. We support ready integration with all that. You also get here counters, right? You can see here that I've made 4 requests to /UI, and I had a status code of 200, right? If I want to see a deeper look, if I want to have a deeper look at the requests that were made into the application, I can go to trace. And trace shows me the request log, if you will, the HTTP verbs, the endpoints, the headers, and so on. It's by default limited to the last 100 requests. And of course, you can configure where this is written out and extend it and so on. But all that is there. I can go to mappings. Mapping shows me which endpoints are exposed to HTTP traffic under Spring Boot. And you can see I've got, for example, the reservations.php endpoint that supports HTTP GET, and it's managed by this component. This shows you everything. This is very good for auditing and so on. If I want to see an enumeration of the environment in which the application is running, I can go to /env. env shows me the system properties as well as the system.get properties. And you can see here that sensitive information like my artifactory password is masked off, inaccessible, right? I can go to, of course, info. Now, info is otherwise empty. You're supposed to customize this. Put the git commit ID, for example, or the service ID or the version using Maven resource filtering. That's very easy, right? To support continuous delivery sort of use cases. And of course, we have health. Now, health is useful in of itself. It returns a status code. It returns HTTP 200 by default. You can invalidate nodes from a load balancer ensemble if you need to, and so on. But what I want to do is I want to customize some of this behavior. First of all, I don't want my endpoints just out in the open like that. And second of all, I want to contribute my own custom health indicator. So I'm going to go ahead and do that here. First of all, I'll go to application.properties. And I'm going to use one of these many different properties that I access by using control space or auto-completion. This auto-completion is driven by an SPI inside of Spring Boot that other IDEs take advantage of as well. So IntelliJ, NetBeans, and Eclipse all provide support for this auto-completion. It's based on the types that are on the class path at the time. So for example, I can say management.contextPath equals /admin. This tells Spring Boot that the management endpoints, the health, the beans, the metrics, etc., should be under /admin. I can also contribute a custom health indicator, right? So I'll say health indicator, return new health indicator, and I'm gonna just there we go, return health dot status I heart Voxxed. Oops, there we are. That was hard. I can build it. I'm using a custom status here, but of course I can just say down or out of service or whatever. I'm just going to say status, and of course this lends itself very nicely to a lambda. So there's that, and we'll hit go. And when this starts up, you'll see that I've got this information customized, and these properties in particular are where I would look first in order to make customization. So of course this will no longer work, but if I go to /health or /admin health, I can see that my endpoint is there and it responds and it gives me my custom information as well. This information is available through different channels as well, not just through REST. I can go here, for example, to JMX and click on these endpoints. Here, insecure connection, mbeans, org, Spring Framework endpoints, beans endpoint operations. There you go. So there's the beans that are wired up in Spring, etc., and the health endpoint and all that stuff, right? So there's that. That's one way to get it. My favorite way to get at this information is to use the remote shell, which is on the class path. So you saw that I added Spring Boot start a remote shell. Absent any Spring security configuration, it's going to print me a default password and a user called user. So I'll say SSH-P 2000 user at 127.0.0.1, paste in the password that I've given on the shell. And here I've got some options. I can say help, and it says, okay, well, metrics, show me the metrics. And these are the metrics, live, animated, and I'm not touching them, they're just updating live. I can also show you, for example, system, prop, ls. My favorite endpoint here is dashboard, right? So there's dashboard right there. It shows you a running Java top of all the applications, if you will. So this is all information about the application that you get for free. It shows you the memory, the running processes, etc. One of my favorite features about Spring Boot is that we want you to get to production and we want to make it as easy as possible. So if you're looking at this application, you can go here to the, I'm going to say Maven -d skip tests because no time equals true, clean install, and whoop, that's not going to do anything useful. Up, downloads, reservation service, Maven. Okay. Come on, CD, target. And what you'll see here is I've got a fat jar, right? This is a jar that has everything I need to be able to deploy this application into production. I don't have to worry about operationalizing it. It contains the embedded SSH server, it contains JMX, it contains an embedded web server, it contains vaadin, it contains all of Hibernate, it contains everything, right? So it's all here. I can chuck this into an email, send it to somebody, and then my grandpa, by virtue of the fact that he can run applets, he can run this. So if operations complains that they can't run this, you can fire them. I checked the law, it's fine. It's okay, it's fine. So now I'm gonna also want to be able to manage this application. I can do cf push -p if I'm using Cloud Foundry, for example, .jar, and that'll push it to an app, or I can run it. Now, of course, you know that I can do this, java -jar, reservation service.jar. That's fine. If I want to override things like the server port, for example, I could say java -d server.port equals 8000 -jar, reservation service.jar, and that'll start up, and you'll see it eventually spin up on port 8000 here. But I want to override, I want to override things a little bit more naturally. So here's port 8000. There's that. That works, of course. And I can also use environment variables. I can also use environment variables, right? So I can say export port equals 8010, for example, and that'll override the value as well. But what I think is interesting is this. This is a feature that we've added in Spring Boot 1.3 called executable jars, right? So I showed you the fat jar support. That's been there forever. One thing that you have to do with the fat jar is you have to write a script to manage it, to stop it, to start it, to status it, and so on. So we've done that for you. Quick show of hands. Does the JVM, did you know that the JVM loads jar files from the bottom of the archive up? and the operating system loads things from the top of the archive down. So the benefit here is that we can do some crazy witchcraft like this. This is the jar, but notice that it says shell script, shell script, shell script, shell script, shell script, shell script, bytecode, right? What we're doing here is we've got a little script that you can now execute like that, and you get your application. But this application responds to status, to up, to start, to all the stuff that you need for init and systemd. So it makes it dead simple to operationalize this application as quick as possible. Now, we've only covered just a little bit today. I'm sorry about that. We're kind of out of time, so I appreciate you sticking along for the journey. One thing that you need to appreciate when you're using Spring Boot is that all of this magic is based on the power of Spring.factories. All that is happening is that each jar contributes Java configuration classes in this enable auto configuration line. These are Java configuration classes that define things that Spring Boot will use to configure the application. We have the ability to conditionalize this configuration based on this. For example, I'm saying only if the type rabbit template is on the class path, then should this Java configuration be evaluated. Or if this bean is not already defined, a bean of type rabbit template, then this bean definition provider should be evaluated. That means that we can create very dynamic environments in which things come to life simply by the availability of beans or objects on the class path. Now, thank you very much for your time, my friends. I appreciate it. If you have questions, I'll be happy to take them off stage. And I'm sorry to have kept you from lunch. Thank you so much.